Hey, Space Frontiersmen! Welcome back to our channel, where we dive deep into the cosmos and explore the latest in space, science, and technology. Venus, often referred to as Earth's twin due to its similar size and composition, is a planet of extremes. Despite these similarities, Venus is a world that is vastly different from our own. Today, we will explore the extreme conditions on Venus and discuss the intriguing question of whether life could exist in such a hostile environment. Before we go into our explanation, we have a very small request. If you like our content, please support us by subscribing to our channel. It's a small click for you, but for us, it means a lot. Thank you. Let's begin. First, let's talk about the atmosphere of Venus. The atmosphere is composed primarily of carbon dioxide with clouds of sulfuric acid, making it incredibly dense and toxic. The atmospheric pressure at the surface is about 92 times that of Earth, equivalent to the pressure found 900 meters underwater in Earth's oceans. This immense pressure would crush most human-made objects. The thick atmosphere also creates a runaway greenhouse effect, trapping heat and causing surface temperatures to soar to around 467 degrees Celsius, or 872 degrees Fahrenheit. This is hotter than the surface of Mercury, despite Venus being nearly twice as far from the Sun. The heat is so intense that it can melt lead, zinc, and many other metals. The clouds of Venus are another fascinating aspect. They are composed of sulfuric acid droplets, which are highly corrosive. These clouds reflect about 75% of the sunlight that reaches Venus, making the planet appear very bright in our sky. However, this also means that very little sunlight reaches the surface, creating a perpetual twilight. The surface of Venus is a rocky volcanic landscape. It is dotted with thousands of volcanoes, some of which may still be active. The surface is relatively young, geologically speaking, with estimates suggesting it is between 300 to 500 million years old. This youthfulness is likely due to a process called resurfacing, where volcanic activity periodically renews the surface. Venus also has a unique feature known as tesserae, which are highly deformed regions of the crust that appear as complex, interwoven patterns. These tesserae are thought to be among the oldest surfaces on Venus and may hold clues to the planet's geological history. Now, let's address the question of potential for life on Venus. Given the extreme conditions on the surface, it seems unlikely that life as we know it could exist there. The high temperatures, crushing pressures, and corrosive atmosphere create an environment that is inhospitable to most known forms of life. However, the possibility of life cannot be entirely ruled out. Some scientists have speculated that microbial life could exist in the upper atmosphere of Venus, where conditions are less extreme. At altitudes of about 50 to 60 kilometers, the temperature and pressure are much more Earth-like, and there is even the presence of water vapor. In 2020, a team of scientists announced the detection of phosphine gas in the atmosphere of Venus. On Earth, phosphine is produced by microbial life in anaerobic environments, where oxygen is absent. This discovery sparked a flurry of excitement and debate within the scientific community. While the presence of phosphine is not definitive proof of life, it is a tantalizing hint that warrants further investigation. To explore this possibility, future missions to Venus are being planned. NASA's Da Vinci Plus and Veritas missions, as well as the European Space Agency's Envision mission, aim to study the atmosphere and surface of Venus in greater detail. These missions will help us understand the planet's geology, climate, and potential habitability. In addition to these missions, there are proposals for aerial platforms, such as balloons or drones, that could float in the upper atmosphere of Venus. These platforms could carry instruments to search for signs of life and study the atmospheric chemistry in situ. The study of Venus also has implications for our understanding of exoplanets. Many exoplanets discovered in the habitable zones of their stars are similar in size to Venus. By studying Venus, we can learn more about the conditions that might exist on these distant worlds and refine our search for habitable planets beyond our solar system. In conclusion, Venus is a planet of extremes with conditions that are vastly different from those on Earth. Its dense, toxic atmosphere, scorching temperatures, and volcanic landscape create an environment that is inhospitable to most known forms of life. However, the possibility of microbial life in the upper atmosphere remains an intriguing question that scientists are eager to explore. As we continue to study Venus through upcoming missions and innovative technologies, we may uncover new insights into the planet's history, geology, and potential for life. These discoveries will not only deepen our understanding of Venus, but also enhance our knowledge of planetary science and the potential for life elsewhere in the universe. Thank you for joining us on this journey to explore the extreme conditions and potential for life on Venus. Don't forget to like, subscribe, and hit the bell icon to stay updated on all things space and science. Until next time, keep looking up.